chemical reactions take place all the time. Now, these are where different chemicals are produced. This is not where you just mix things together and have a mixture. This actually has a chemical reaction. And these chemical reactions we probably have more of these than you think we have. Now, let's go back to a chemical reaction that you are familiar with. This is the photosynthesis formula. You may remember from a year back that you have carbon dioxide plus water is going to yield this glucose, C6H12O6, and oxygen. Now, this is an example of a chemical reaction equation. Now, one thing I want you to notice is that you have the same number of hydrogen molecules, the same number of carbon molecules, and the same number of hydrogen atoms, same number of carbon atoms, and same number of oxygen atoms on both sides of the equation. Now, let me point this out to you. Let's talk hydrogen first. H2O has 2 hydrogens for every oxygen, and if you have 6 H2O molecules, that means 6 times 2 is 12 hydrogen atoms you have on this side of the equation. So if you look on this side of the equation, the only H you see has a 12 beside it. So that means equal number of hydrogen atoms on either side of the equation. You're going to find that's going to be the same for C. If you multiply out how many C's are over here and how many C's are over here, you'll find 6. And the same thing's going to be true for O. Looks like you have a bunch of these over here. Look like 12 and 6 more over here. And that's going to end up being the same over here. So that's going to be one of the characteristics of chemical reactions, that you have the same number of atoms on both sides. Now that's going to be true for every single element that is on either side of the equation. So what it boils down to is that nothing new is created and nothing old is destroyed. It's that law of conservation of mass. I thought I had this written down here, but I don't. It's the law of conservation of mass. We've studied it before. Anytime you have a chemical reaction, nothing is created or destroyed. Now, one thing I do want to point out is to start the reaction, you have to have energy. In fact, I think they have labeled it right here in the middle. You have to have energy just to start the reaction to break these bonds. Now, this energy can be in many forms. It could be like the heat you would have with a match here. And that match would end up burning something like gasoline. It could be light energy like it is in the photosynthesis formula right here. So that energy can come in many different forms. Now, energy is also released. Energy is also released when the chemical reaction takes place. So you have energy that is put in and energy that is released along with what is resulted here. You have the reactants and the products here. So you have energy comes in to break the bonds, and whenever it forms this, energy is released also. And that's going to bring us to these terms, endothermic and exothermic. When there is more energy on this left side of the equation, it's considered endothermic. Now, most of the equations that have to do with human beings and with anything living, any chemical reaction with anything living, is usually endothermic. You have more, photosynthesis is too, you have more energy that comes in than actually goes out of this chemical reaction. And of course, exothermic is where you have more energy that comes out on this other side. Now, here's a good example. A match, it doesn't take much energy into striking a match, but you have a lot more energy from the flame that is released. You have heat energy. So not much effort or energy taken to strike the match, but a lot of energy is released, and that's a good example here. Exothermic would be like the match and the heat released. Endothermic would be more like photosynthesis here. Now let's list some kinds of reactions. In fact, I have 4 kinds of reactions here. 1, 2, 3, 4. Wow, that's a pitiful little 3 right there. But I'll try to lengthen that out. 4 kinds of reactions over here. One reaction is the synthesis reaction. The synthesis reaction is basically when you're taking 2 elements and combining them and forming your compound. Kind of like right over here. You're taking hydrogen, you're taking oxygen, put them together, and this arrow means yields. These 2 reactants yield the product, which is going to be the H2O right here. So whenever you have that happen, this is also called polymerization, which means that what you get is going to be called polymers. I guess I should say it different. It's not what you get. It's what you put into it are called polymers, P-O-L-Y-M-E-R-S. I'm sorry, the products are going to be polymers. So what you get is what you get out of it. Will be the polymers in polymerization. So if you have like NaCl, it starts with the Na plus the Cl, and that turns out to be the polymer of salt. Now, we don't normally think of salt as a polymer, but just by definition, the synthesis reaction is going to be polymerization and will create polymers. Now, polymerization can occur when radicals form. Another definition here. A radical has at least 1 electron available for bonding. Now, we've talked about bonds a lot in this class. So you could consider all those ions that we've talked about on either side of the periodic table. You could consider them radicals, and they form the covalent bonds. Now, whenever I say on the left-hand side, that would be metals, but I'm talking about the hydrogen. So radicals form covalent bonds, and they have ions. Let me say it again. Radicals have ions, and they form covalent bonds, and you'll have the synthesis reaction here. I mean, something with an ion here plus something with an ion here produces a covalent bond, just like water is over here. Second kind of reaction is the opposite. That's the decomposition. You have something, some kind of compound, and it breaks down, it decomposes into its original elements, just like the opposite here. Say you have H2O that breaks down into 2 hydrogen and 2 oxygen. Now, this is something that doesn't happen that much in nature, but you notice it has electricity here. You can do that apparently some with electricity. Okay, we have a third kind of reaction in a single displacement reaction. Here's where you have basically A and B flipping out. I say flipping out. They're going to be exchanging with their bond with C. Originally, there's one element which has bonded with C, and through a reaction, the A kind of takes its place. Now, what's going to happen here is you often have something that is very reactable, which is A. And you may remember the whole left-hand side of the periodic table, those alkali metals are very reactable. They react with quite a lot of things. And this is usually what happens here. You have an alkali metal, which is often A, and something that is like B, which is not as reactable. So the reactable element or metal in this case just takes the place of it. Kind of like this. Now, this is not an alkali metal, but it's a metal. It has taken the place of Cu here. So what results is this iron, Fe, pretty much just kicked out the Cu, and now it is forming the bond with the ion SO4, which is different from a double displacement reaction. A double displacement reaction is where you have A, B, C, and D, which pretty much just completely mix up. So instead of being formed with B, A will now be formed with D, and instead of being formed with D, C will now be formed with B. Just pretty much a swap. It involves 4 different elements as opposed to the 3 different elements of the single displacement. You can see an example down here. We have BA, which used to be with Cl2, and the BA and the Cl2 have been completely split up, just like the Mg, magnesium, and SO4 have been completely split up, and that's the double displacement reaction. And I'm looking back over my notes, and there was something I forgot to tell you about the single displacement reaction. The single displacement reaction, hydrogen gas often explodes when you have an alkali metal which forces a single displacement reaction. So if you have hydrogen gas, which is the one that is displaced, it often explodes. Kind of an interesting aspect to that. There are a couple of other things. There's something called a combustible reaction. A combustible reaction is whenever you have oxygen, where you have at least one reactant is oxygen. Now we know that combustible is usually synonymous with an explosion. And by definition, it doesn't always have to explode. But we know that oxygen, for example, helps feed a fire. So that might be a way you can remember it whenever you have a reaction, one of these reactions which has oxygen in it. And if I'm thinking correctly, that will usually be in decomposition. You know, decomposition is whenever you had one that breaks down, like you had a compound A, B, and it turned out to be like A plus B. Sorry about the bad mistake there. Okay, let's talk now about reduction oxidation reaction. Here's what your book says. This is a reaction where electrons are transferred from one reactant to another, kind of like an ionic bond. Whenever you have, well, here's an example right here. We have the ions of Na, you know, Na is going to be +1, and bromine is going to be -1. So whenever you have a compound, and this is kind of something you already knew, whenever you have sodium and bromine that are put together, then you have that one extra ion that has kind of flown from one side of the periodic table to something that's on the other side of the periodic table. Now I'm being kind of dramatic there, but still all of these in the alkali metal category are going to want to give up their electrons. And all of these on the other side are going to want to accept those electrons. So this is often called a reduction oxidation reaction. And you see what is oxidized. What's oxidized is going to be the one that is giving up the ion, the electron, and what is reduced is going to be the one that is accepting the ion and that, or the electron, and that is often called a redox. You can see how reduction and oxidation, a redox reaction. So I hope you've learned a little bit about these kinds of chemical reactions.